Hello everybody, and thank you for choosing to watch another video from this channel. Today I'm going to talk about Alginic acid gel and different type of Alginic acid gel that you can make at home. For chemists who are doing reverse engineering, I will later talk about the analytical aspect of this work, and I will tell you a method that you can use for the quantitation of this excipient in your pharmaceutical product. I have three different alginic acid here. I have so-called very low viscosity alginic acid, medium viscosity alginic acid, and high viscosity alginic acid. There are three types of them, and these are in the powder form. They are all supplied by Alpha Chemical, 1, 2, and 3 of them. And these solutions that we see here are the 1% solutions. So they are being, the material are being dispersed in water with high agitation, and then they're being solvated overnight. Now if you have a homogenizer like this machine that I have here, then the process would be much faster. But if you don't have a homogenizer, probably you can use the hand blender, high shear hand blender at home. I can tell you that these homogenizers are no cheap, and just this blade itself is more than $1,000, or maybe more, a lot more. But on the other hand, the high shear mixer that you can buy at your store near your home is probably less than $100 or $50 or whatever it is. So you could use those equipment as well. For comparison purpose, I also have my Carbomer 1% made, and also the xanthan gum 1% solution. So I'm going to just visually show you how they look like, and I'm going to put these away that I can have a better reach, and so this machine away. And viscosity wise, the very low viscosity indeed has a very low. It's like a water, liquid water, and this is the similar grade that I demonstrated in my previous video about comparing the alginic acid versus carbomer and the xanthan gum. On the other hand, the medium grade viscosity, for sure, it still look like a liquid, but it looks like a viscous liquid. It is not as the other one, which look like like water floating. And then the high viscosity, for sure, it feels like a gel, but it does flow. Maybe I can use the spoon a little bit and show you the viscosity. So it is like it's dripping, and it does indeed look like a gel material. I'm gonna just grab a napkin and clean my. Now, in comparison with 1% carbomer, we see that the carbomer definitely is a gel, and these materials have higher viscosity, much higher viscosity. Okay, I made a little message here. Much higher viscosity than alginic acid. So, as I said in my previous video, if you like to make a gel product like a hair gel, your carbomer is the polymer of the choice. Now, xanthan gum 1% viscosity, these are just for comparison, are very much similar to high viscosity alginic acid. So now it is your choice. I mean, which polymer you want to use, and I will talk about the different aspects of this polymers later on in this video. About the carbomer is not a food grade, probably you cannot eat it, whereas the alginic acid is food grade, and so on. Before I go to the analytical aspect, I would like to do a little bit of the fun chemistry, which is adding calcium chloride to alginic acid. So I'm going to, in theory, you have to have the 1:1% ratio to have this special effect. But I'm not measuring it, it's just by hand, I added a little bit. I tried to dissolve the calcium chloride and make a rather concentrated solution. I'm going to transfer these sodium alginate polymer into different beakers and show you that by adding the calcium chloride we will significantly increase the viscosity of this material significantly. And you may see other videos about the calcium chloride alginic acid in YouTube, and probably are more entertaining, but this is what I'm going to do just today. First of all, as I said, this is very liquidy, and I'm going to add a little bit of calcium chloride here. You can see this is immediately forming a solid, and I'll do the same thing with the medium viscosity. Again, it does immediately form solid material, and we'll also run out of calcium chloride solution. I'm going to make a little bit more. And for sure, now if I add it to the high viscosity alginic acid, the polymer that I'm going to make would have a higher density than the other ones. And also it does matter how much calcium you're adding. So I add a little bit here. Again, it immediately forms some solid material. Solid material is like a goo, right? We can actually lift it up. I'm going to mix this one, mix that one. And I think I'm going to grab a glove. I don't want to touch this stuff. And so this is like a goo, like a solid goo, and you can actually play with it. It's like a Play-Doh of some sort. And same stuff I can have here, a little bit more fragile. The structure is not as strong as the high density, and similar as the other one, that you form a solid material, solid goo. So this goo for sure has a different structure than the one that we don't have calcium chloride. What is happening here is that the calcium will act as a binder and start to link the straight chain polymer of the alginic acid together. So you will start to making this 3D structure. Now the question is, does it happen if I add calcium chloride? Does it happen to the other polymers that I have? I need to make a little bit more calcium chloride. So we definitely did make a lot of glue and a lot of mass in here by adding calcium chloride to, wow, this is really messy, I apologize. So the question is that if I add calcium chloride to, let's say, carbomer, do I get the same effect? Do I increase my viscosity higher than what I have already? So I'm going to add a little bit to this beaker, and you see that this carbomer already have high viscosity, and it is clear gel. It is just fantastic for people who want to do gel formulation. And I'm adding calcium chloride to it, and by adding calcium chloride, actually what happens is opposite. I start forming the precipitate, and it completely destroys the gel structure. So this is without calcium chloride, it is with calcium chloride. So in the case of alginic acid, we see by adding calcium chloride we end up increasing the viscosity significantly higher, and in the case of carbon it is opposite. We actually destroy the gel. And in case of carbomer, xanthan gum, it is, I don't have any more beaker, but I will add a little bit to this calcium chloride here. And in case of xanthan gum, it does increase viscosity somehow, but not as much. So let me show you a few slides that explains a little bit of chemistry of what is happening here. Okay, I will go back and show you some slides. Okay, so I'm going to talk about the qualitative and quantitative analysis of alginic acid, the cosmetic products. Alginic acid is a polysaccharide that comes from seaweed. So it is extracted from the plants, and it is a gelling agent, and it is a food grade because it is something natural. The alginic acid is a linear copolymer, and it is called it has a G block and an M block, and the M block is the beta D manoronate sugar, and it has a 1-to-4 link, and the G block is alpha L glucuronate sugar, and depending on the source, the number of these M blocks and G blocks may vary. And somewhere I read that high G block, it is used in pet food, and the low G block used in the food and pharmaceutical industry. Now I show you about the addition of calcium, that it converted sodium alginate gel into something solid, and what is happening is that calcium gets into the G block and makes these linear polymer to link to one another, so you create this 3D structure. Then suddenly you not only increase the viscosity, but actually it becomes like a solid goo. Now it didn't happen to the carbomer, because if you look at the carbomer, it is just a polymer of acrylic acid. So the backbone is just hydrocarbon, which is hydrophilic, and the section, or the part that creates this gel structure, is your carboxylic acid moiety. So in case of carbomer, we have this calcium binding to your carboxylic acid, and it pretty much destroys the gel structure, because the backbone doesn't have any hydrophilicity. But in the case of xanthan gum, the backbone is alpha D glucose, and it has a whole bunch of OHs. Although it has a carboxylic acid, and maybe it binds to the calcium, maybe reduces, maybe creates some sort of 3D gel structure, but because your backbone has so much of the OH group, the gel structure is not destroyed. So this is a little bit of a chemistry about what is going on with the calcium addition. Sodium alginate is used as a thickening agent, a stabilizer in the food industry. It is heavily used in ice cream, yogurt, puddings, cheese, probably in the products that they talk about the low calorie or 0 calorie products. In pharmaceutical industry, also used for binding the tablets, as like binder, or some other products. Also, there is a line at the bottom that it says alginic acid does not appear to be absorbed nor metabolized by body. So it is my opinion, if body cannot digest it, it's probably is not something that I would like to eat a large quantity of it. So let's say pudding made of alginic acid, it's my opinion, I probably wouldn't eat it. Now for qualitative and quantitative analysis, I'm going to talk about HPLC, RI, and probably viscosity. So with these two techniques, you can do the quantitation and you can do the grade determination. This is the chromatography of alginic acid, and this peak around 22 minutes is your alginic acid. And in this particular formulation, I also had the xanthan gum. So these two are well separated. And there are other excipients in the formulation that shows at the other peaks after 25 minutes. This method is isocratic, uses a reflective index detector, and the medium is definitely a buffer, so you have to keep the pH at 5.8, and the column is size exclusion chromatography. I rather not to endorse any type of column or give you details about it. Probably if you have a size exclusion column in your laboratory, just look at the specification, see the buffer that you can use for your column, and just it shouldn't stop you from trying. If I say I am using column ABC, then you tell yourself, oh, I don't have ABC, so then forget about it. No, try it, and you probably will generate chromatography similar to what I have, with probably different methods, even maybe different buffer. So with this method that I'm showing you, you can easily do the quantitation. How about the grade determination? Does this method can tell you what grade you have? Sure it does. I have shown you the 3 chromatogram of the gel that I showed you earlier, the low, medium, high, or we call it very low, low, and a high viscosity. So the line in blue is a high viscosity alginic polymer, or sodium alginate salt polymer. The one in the middle is a low viscosity, and the red one is very low. So by comparing these 3 chromatograms or peaks with the peak that you have in your finished product, or the product that you're trying to reverse engineer, you can definitely tell which grade of alginic sodium alginate they use in the formulation. So with this method, you can easily do amount and the grade determination. Probably another test that you would like to do is the viscosity. And so you want to make the product and then determine the viscosity of your product versus the product that you're reverse engineering. Okay, so I'm going back to my kitchen, and I'm going to try some of these sodium alginate on my skin. I'll tell you how do I feel about it. Okay, see you soon. Okay, so let me just use some of these materials on my hand and describe to you what is the feeling of using this gel material on my skin. And I have to say that this alginic acid video was created because one of the subscribers was asking me about alginic acid, and as I recall, he was asking me if you could substitute alginic acid for the xanthan gum, and he asked my opinion. And well, the opinion is that probably what you need to use is that the high viscosity alginic acid, which has a similar viscosity compared to the xanthan gum, and stay away from the low or medium grade viscosity of alginic acid. And definitely you need to buy sodium alginate. Otherwise, if you buy alginic acid, then you need to go through this pH adjustment process. I think I have shown the low viscosity grade last time, that it is kind of, it doesn't form a gel. It is very much like a liquid, and it doesn't stay under the skin. The mid-grade alginic acid, it stays a little bit longer, and definitely it feels like a gel, but actually it's very liquidy, and but it is just liquidy, very liquidy gel. Let me clean my hand before I put the other grades. And I have read somewhere that these sodium alginate are supposed to make a film on your skin, and I'm just kind of rubbing it, and well, this is like a wet. My hand is wet. And I'm gonna use the high viscosity alginate. This is definitely gel. These are, my description is very much depending on whoever does it. There's no scientific, it's not scientific experiment here, and it's very subjective. You know, I may say I like it, maybe someone else I don't like it. And as the water starts to evaporate, I feel that it is kind of like getting a little bit sticky, and the stuff, the feeling is not very pleasant. I put it this way, I didn't like it. I just didn't like to put alginic acid on my hand. It is maybe there are more. It is rather sticky. Yes, it definitely does. And I'm gonna rinse my hand before I put the other stuff. Again, maybe someone else likes it. Maybe alginic acid or sodium alginate does work magic in their formulation. So, but this is my my feeling. Just putting 1% gel. How is it gonna feel like? So I put in the xanthan gum. Well, the texture. Okay, this is definitely more slippery than alginic acid, and it does not have this sticky feeling that I had before. Maybe I have to wait till the water evaporates a little more, but definitely it feels like a more lubricating rather than putting gel material which is sticky. This is definitely more slippery, put it this way. For sure there's a difference here. It's more slippery. And carbomer, well, I just put it on top of the alginic acid. Okay, carbomer is definitely not as slippery as xanthan gum. For sure it's not. As I said, if you use hand sanitizer, this is probably the same feeling. But keep in mind that hand sanitizer, instead of water in the carbomer, they use 70% ethanol, or the denatured ethanol. So if I want to use some sort of gel formulation, my preference would have been the xanthan gum. And thank you very much for watching this video. And if you like it, I appreciate you push the like button. Definitely I would like to hear your opinion about this video. If you have experience working with this gel material, if I have missed something, which I definitely did, please write a comment for me. And I appreciate you taking your time and being with me and listening to my stuff about alginic acid. Have a good day. Bye-bye.